Hello, Numerade. Welcome back. Okay, so Chapter 4, Section 4 of Thomas's Calculus 14th edition, page 214 of the textbook, question 125. We're given y is 2x to the fourth minus 4x squared plus 1, and we're asked to discuss what the first and second derivatives tell you about the graph of y. So what's the first derivative? You could do this numerically on the calculator if you want. It's going to be 8x cubed minus 8x. So when is that 0? If you take out 8x, you got x cubed minus 1. So I guess there's a real 0 at x equals 1. So there's a possible, let's see. Well, there's 3 roots here, right? So at x equals 0 and at x equals 1, let's see, at x equals 0. All right, let's continue. And then the second derivative would be 24x squared minus 8. If you take out an 8, that's 3x squared minus 1. So you have 2 possible roots. X squared. Oh yeah, the square root of plus or minus 1. So there's two possible mins and maxes at plus and minus 1 and at 0, so it's 3. And then 2 possible inflection points. Because this has 2 zeros too. This is a quadratic. Okay. And they're real roots, right? Okay. So we should probably see 2 inflection points if the second derivative changes sign there, and 3 critical points, so 3 extrema. If again the derivative changes sign there, and they're asking to use a computer or a calculator, I suppose would suffice. So let's see to investigate that, right? So here we go. So let me clear out the last problem we had. All right, so let's see what the function looks like. 2x to the fourth. So quarta could have as many as 4 zeros. Get out of the exponent. Minus 4x squared plus 1, 4 real zeros. At most 4 different real zeros. They don't have to be different. They don't have to be real. So let's see what this looks like. Okay, graph. How about a zoom 4? If that's not good enough, we'll change x min x max or y min y max appropriately. Oh, there's your 4 zeros. Oh, there you go. So there's a local min here, -1, a local min here, +1, and local max here at 0. And then 2 inflection points somewhere around, I don't know, -0.5, +0.5 roughly. Let's find out what that is. Okay, so y equals, let's see the second derivative, at 8x cubed. So we should see zeros of this function where the extrema occur. I did it again. 8x cubed, get out of the exponent, minus 8x. Okay, let's graph this in the same window. So the red curve is got a 0 at -1, and a 0 at 0, and a 0 +1. Right. Okay, good. And then it's negative before -1, so the blue curve is decreasing, then it's increasing because positive red curve y values, right? So that's first derivative test gives you a min, and then it's positive to negative, so max, and then it's negative to positive, so min. That's perfect. Okay, what about the inflection points? The inflection points are at the zeros of this thing, 24x squared minus 8. It's a black curve. And the inflection points occur right there. Okay, so let's find what that is. Second count 0 on the black curve. There you go. Let's get close to the 0 for that curve. A little bit to the left, a little bit to the right. Enter, you don't have to guess. about 0.577-ish. What's that? The cube root of 1/3 or something? Yeah, probably. Yeah, 1 over rad 3. Right. Yeah, that sounds about right. And then by symmetry, that's negative. By symmetry, a positive value of the same amount. So I can count the 0 on the black curve. Let's go to the other 0. To the left of it. Come on. Whoops, past it. Right there's good. Then past it. Right there's good. Then hit enter. You're off to guess. Positive 0.577. Yep, there it is. Alrighty. And what about what are the local mins and maxes? Okay, so second calc min on the blue curve. Let's go to the left of the first min, tracing the blue curve. And so it occurs at -1, comma what? That's basically -1, comma -1. Okay. And because the 0 is clearly of this thing. 0 plus or minus 1. You just do that in your head if you want. You can check the zeros of the right curve on here if you want. Okay, second calc max is at 0 something. So a little bit to the left of that, enter, a little bit to the right of that on the blue curve, looking for the relative max, local max, enter, don't have to guess, and it's at 0. That's basically 0 with a roundup error, 0, 1. And second calc for the min. Let's get over there. Move it to the left of the min, go past it, enter, and then it's at +1, -1. There you go. So the min is -1. So a min at -1 for x, the min value is -1. A min at +1 for x, the min is -1. A max at x equals 0, and the max is y equals 1. Okay, I think that covers all bases. Good luck with your homework. Hopefully that was helpful. See you next time. Bye-bye.